Have you ever wondered what makes some things just click, while other things feel almost impossible to learn? Today, we're diving into the hidden rules that control how our brains tackle new information.
I mean, it's a question we've all asked ourselves, right? Whether you're picking up a new language or just trying to figure out the rules to a new board game. Well, it turns out the answer isn't just about how smart you are. It has a lot more to do with a concept called information.
Because you see, learning isn't really about stuffing your head with facts. It's about reducing uncertainty. And that simple but powerful idea is what we're going to unpack today.
To really get a handle on this, we first have to look at a huge puzzle that scientists have been trying to solve for ages. How in the world do you measure how difficult something is?
Think about that for a second. A single, universal ruler for learning. If we could actually create that, it would be a total game changer. We could redesign how we teach everything, making it all more intuitive for pretty much everyone.
So the first big attempt to create this ruler was really logical. But, as we're about to see, it only gave us part of the answer.
This first idea was called Boolean complexity, and it was pretty straightforward. The more complicated the logical rule to describe something, like it has to be big and red, or it has to be small and blue, well, the harder it should be to learn. Makes sense, right? And this approach actually worked for a little while. It could predict one specific way that we learn things, but it completely missed another pattern that kept popping up in experiments. There was definitely a piece of the puzzle missing.
So the main takeaway here is that logic is part of the story, for sure, but it is not the whole story. We needed a new idea, something a bit more powerful, to see the complete picture.
And that new idea is called information complexity. It completely shifts the focus away from logic and puts it squarely on uncertainty.
So instead of counting up logical rules, information complexity asks a much cooler question. Once you know a few things about an object, how much uncertainty is still left? How much more information do you really need to figure out what it is?
This is such a great way to think about it. Imagine you have all the edge pieces of a jigsaw puzzle put together. The information complexity is basically how hard the rest of that puzzle still is. If the edge pieces gave you huge clues, the uncertainty is low. But if they don't really help you at all, well, the uncertainty is sky high.
And we're not just talking about a vague feeling of uncertainty. Nope, this is a precise mathematical value you can actually calculate, using something called Shannon entropy. You can think of it as a measure of pure surprise. The more unpredictable something is, the higher its entropy.
Okay, and this is where information complexity becomes like the superstar of the show, because it managed to solve two really confusing problems at the exact same time.
So remember how the old theories could only explain one learning pattern? Well, for the longest time, researchers kept seeing these two totally different patterns of difficulty pop up in their experiments, and nobody could figure out why.
So on one hand, you have this paradigm-specific order, which showed up when people were sorting objects with really obvious features, like shape. But then this other general order of difficulty appeared when the features were super subtle, like trying to tell apart different shades of the same color. And what's really wild is that this second pattern also showed up in studies with kids and even monkeys, which suggests it might be a more basic, fundamental way of learning.
The big aha moment came when scientists realized information complexity could predict both of these patterns. The trick was all in how you calculate the uncertainty. If you look at the absolute minimum uncertainty possible, you get the first pattern. But if you look at the average uncertainty, you get the other one. It was this beautiful, unifying insight. And that is what makes this idea so incredibly powerful. Where the old theories only saw one side of the coin, this new approach revealed the underlying principle that connected both sides. It finally gave us a single, unified theory for what looked like two totally different kinds of learning.
So you might be asking, why does this all matter so much? Well, because measuring uncertainty this way connects the psychology of how we learn to a much, much bigger scientific picture.
The idea of Shannon entropy isn't just for this one thing. It's at the core of how we build models of our own cognitive systems. It helps explain the information bottleneck, this idea that our brains can't process everything, so they have to choose what's important. It's even used to measure our basic ability to tell things apart. It really is a fundamental building block of cognitive science.
Okay, so let's pull this all together. What's the new, clearer picture of learning that we're left with?
Here are the big takeaways. First, information complexity gives us a way to measure the real cognitive cost of learning by focusing on that leftover uncertainty. Second, it brilliantly predicts those two learning patterns that its scientists stumped for so long. And finally, it grounds our whole understanding of learning in the solid, proven world of information theory.
And that leaves us with a pretty mind-bending final thought. We've used this amazing tool to finally understand learning difficulty. But if we can measure the hidden uncertainty in literally any task, what other secrets of the mind, from creativity to how we make decisions, are we just on the verge of unlocking?